All right, so you're working on predicting reaction products, and I'm going to go through and do examples, one or two examples from each section. So first we have synthesis. So remember, that's two things coming together to make one thing. So tin could have a +2 or a +4 charge, kind of to make it easier. If tin has a +2 charge, then it would combine with 2 chlorine and we don't have to balance the equation, so that's good. Zinc has a +2 charge when it's in an ionic compound, so it will bond with 2 fluorine because each fluorine has a -1 charge, and then we don't have to balance the equation. Once you get down to things like barium oxide, so remember, barium is a +2 charge, oxygen is a -2 charge, so it would need to be BaO. You'd have to have 2 of these, which means you'd have to have 2 barium. All right, let's go to decomposition. So that's breaking down into its parts. First off, we would break down into nitrogen and hydrogen. But remember, nitrogen and hydrogen are both diatomic, so they need to have their 2 next to them. Then we would need to balance. If we have 3 hydrogen here and 2 here, we would need to come up with a common denominator, so to say. So that would be 6. So we're going to multiply this by 3, this by 2, and everything becomes balanced. Down here, we've got sulfur and hydrogen. Remember that hydrogen's diatomic. Everything's balanced. Now we can go to single replacement reactions. These are ones where we're going to practice our redox as well. So we've got copper and silver nitrate. If we predict the products of that to determine if a reaction would occur, we need to figure out, is copper higher on the activity series than silver? So when we take a look at our activity series, copper is right here, silver is right here. It is higher, so they will replace. So we end up with copper nitrate and silver. Let's say that we have copper, which has an oxidative state of 0. Silver in this case is +1, and your nitrate is -1. Now we have copper in a +1 state and silver in a 0 state. So copper is going to lose 1 electron, and silver is going to gain 1 electron. So remember, Leo, lose electron, oxidize, says Ger, gain electron, reduced. So that means that silver is reduced and copper is oxidized. We could go down a little bit further. Let's see. How about sodium and magnesium chloride? We've got sodium up here, magnesium down here, so sodium will definitely replace magnesium. So NaCl plus magnesium. We need to balance because there's 2 chlorine here, which means we need a 2 here to give us 2 chlorine and a 2 here for sodium. We can look, sodium goes from an oxidated state of 0 to +1, so it is going to lose an electron. Magnesium goes from an oxidative state of +2 to 0, so it gains 2 electrons, and so we have magnesium being reduced and sodium being oxidized. Oops. All right, then that takes us to the back side. We've got our double replacement reaction. So remember, this is where the anions swap. So we have barium swapping its chlorine for carbonate. Carbonate has a -2 charge. Barium has a +2 charge, so they go together in a 1-to-1 ratio. Sodium's going to swap with its carbonate with chlorine. We notice we have 2 chlorine here and 2 sodium here, so we need a 2 out front here, and our reaction is balanced. Then we have, let's go to the bottom, zinc hydroxide. So zinc is going to swap its hydroxide for sulfate. So we go zinc, which is +2. We've got sulfate, which is -2. They come together in a 1-to-1. And then we have hydroxide coming, or hydrogen coming together with hydroxide. When they come together, we get this HOH, which, remember, if we rewrite that, is actually H2O for our water. All right, now we need to balance. We've got 4 hydrogen, so we need a 2 out front here. We've got 2 oxygen there. We've got 1 sulfate and 1 zinc, and we're good. Combustion reactions always have a CO2 and water as their final product. The worst part is balancing, so I always start with the carbon. So if there's a 12 there, I'm going to put a 12 out front here. Then I go to hydrogen. There's 22, which means I need 11 times 2 to give me 22. Now we look at oxygen. I've got 12, 24, plus 11. So I've got 35 oxygen. I have 12 here. Ooh, that looks like 350. I have 12 there, so I would need an odd number there. That odd number would be 23. So since I can't have an odd number, if I take half of that odd number, I get 11.5. I can't have an odd number there, which means I need to double everything. So that means I need to double this, double this, double this, and double this. All right, then we have identifying the reaction types and predicting the products. I'm gonna leave you to that one, and we'll go over this in class. Bye.